All right. So last time we have the last content that I upload last week. That is about the polar and the vectors, right? So everyone watching the video, or or maybe just skip and just write the attendance. Okay. Do you watch the video? Do you watch the video? Okay. So I hope you watch carefully, because at least the polar, you will find this in calculus 2, okay? Okay, so in calculus 2, as an introduction, I would like to say, you will need to, instead of like using the, remember calculus is about derivative and also integrations, okay? If you remember the integral, integration is finding the area, right? Or finding the volume, depends on which context. If you have like this curve, imagine that you need to find the area using integrations. Okay? But before integrations, before we are doing that in calculus 2, we need to know how to make the polar curves at the basic concept, as a basic concept, so the principle. So I think this is all the necessary concept for the polar curve. Okay. So for example, the first polar curve, the common polar curve is the first one here. This is the very basic. Okay. Maybe except the spiral, the circle is very basic, right? So if you look here, if you say you are in the, remember when we talk about polar, we are moving our axis xy. We change our perspective into the polar, which means we are having the polar axis, and how we move is circular. Okay? That is how we move our points. In xy axis, you move points. Imagine like, I think you remember when you first write a letter, you're writing a letter in a rectangular boxes, right? Here you write A, B, right? And then you put boxes. Those boxes is just like your xy axis. You put points and you move the coordinates. Okay? That's the rectangular. That's why we call rectangular axis, because we have some invisible rectangular. Okay? But polar, we have invisible circle. Okay? Invisible circle. So when we say we are having r equal a, r is constant, which means we are having a radius which is a constant a. It can be 2, 1, 5, 4, which means it is a circle with a fixed radius. Okay? And then we talk about the sine or cosine, and we have a constant in the front. The easy way to remember or to notice is every time we talk about sine, it's always talking about the top of the equations or the top of the curve and the bottom part. Okay? So when you are having a positive sign, it will always have it in the top. Okay? You can prove that by taking some value of theta and then the plot into the polar. And remember, this is polar, not xy axis. Okay? And when you have negative, you will have this green color here. Okay? And then when you have cosine, you will have on the left and on the right. The right positive, the left side is negative. It's always like that in every aspect. Okay? So this is very basic. And then when you have a spiral, you will have like this. Okay? Not necessarily be discussed much, but just for your information. And then when we have the something using the a plus minus b sine or a plus minus b cosine, all the curves we call limações. Okay? I'm not sure what's the meaning of limações. Maybe in Spanish, you know the exact meaning. Can you literally? No? Okay. All right. So first, it can be limaçon with inner loop. This is when a is less than b, the value of a. I think it's better to imagine the value like, for example, if you have 1 plus 2 sine. Okay, let's say we have 1 plus 2 sine. Okay. 1 is less than 2. Agree, right? This is less than 2. Remember sine? The maximum value of sine is 1. The minimum value of sine is negative 1, right? So whenever we have this, it says that in this picture, when A is less than B, then it should be limit of the inner loop, which is this is A and this is B. B is attached to the sine, right? So this 1 less than 2. Okay, so it should be this one. But how do we make it into our logic, into our like how do we draw it? Okay. So what I want to say here is, if you plus this, when this is equal 1, it should be 3. Okay. So perhaps this will be 3 here. Okay. And the difference between this, it should be negative 1, but since it's in the polar, it should be the opposite. So the negative 1 should be here. So this is 1. Okay. Okay. I hope you get at least the logic. Okay. If not, then try to make up this graph. Okay, try one by one and taking some special theta. Okay, you will see something like this. Okay. And then when you have A equal B, this is cardio. Cardio is from cardio, from the heart. So it's the same is like a heart. Okay. Okay. Now back to the equation here. If I want to make, for example, 1 minus 2, but sine, how the graph will look like. Now it's minus. How the graph should look like. Anyone want to raise your hand? Yeah. How the graph should be. Okay. If this is 1 plus 2 sine, how about this 1 minus 2? Yes. So you could reverse this and taking the large part on the bottom. Okay? Remember, from this concept, okay? Every time you have a positive sign this way, the more portions on the top. When you have negative, the more portions on the bottom. Okay? When you have cosine, the more portion on the right means it's a positive, the more portion on the left means negative. Okay? So when we have this 1 minus 2 sine theta, this will be going to be, something like that. Okay? Okay? And then the cardio, okay, we back to cardio. So if we have, so you could predict what kind of equations this will be. It's positive sign, so probably 1 plus sine theta can be, okay. So it can be 1 plus sine theta, it can be 2 plus 2 sine theta, as long as the A equal B. Of course, if you look at, because there will be no difference, meaning when you plus this, it's going to be the maximum is maybe 4. 2 plus 2 is 4. The minimum is become 0, which is here, 0. No loop, right? Okay, get it? Okay, and then when we get to the default limison, A is greater than B, but it's different from this part. Okay? So you need to make sure that it has differences. So default limison, you will have not exactly at 0, but maybe around here, and still having this shape. Okay. And then when you have the convex limison, it's like a circle. It's going to be like a circle, but it has this different proportions. Okay. And then you just need to look at this ratio, okay, for A and B. Okay. I think that's the best way I can explain. Maybe later I will put some video to help you to draw, and for all concept of polar. Okay? At least the limison, the rose, and the Leibniz scale. Okay, the rose is this one. Okay, and actually you can combine the rows and the limmason, like you have the rows, but as you have the inner loop, it can be. And then there will be some pattern within the rows. Okay. You have it depends on the n. Okay. When n is odd, it's becoming the number of the leaves. When n is even, it becomes twice of the number of the n here. Okay. And then the last one is the Leibniz scale. It's just having two shapes. This one here, and this one using the cosine. This is the sine. Okay. The rest, I hope you can dig out and find out. Okay, by yourself. Okay, but as an introduction, as I mentioned in the beginning, you will need all this in calculus 2. So if you don't know the basics, then you cannot solve anything in calculus 2. Because in calculus 2, I will preview all the basic curves, but just a quick review, not really, not really deep. Okay, so the polar, and then I expect for I think this is plane curves and parametric. Okay, this is also in calculus 2. At the beginning, calculus 2. So calculus 2 will begin with parametric equations and the polar. So that two part you need to at least familiar with. Okay, this part here. Okay, so parametric is like I think if you solve some physics kinematics, I believe you get this graphs, right? In physics, right? But I think your memory on physics memorized quite a lot, right? Okay, but this is just to say that we will have another variable besides x and y that we can relate to x and y. So we could take the x and y with terms of variable t. Okay, just a quick review. Yeah, this is just a quick review. Yeah, the idea is first eliminating the parameter, and then we have the cycloid. I think this will be on also the introduction on calculus 2. So the cycloid is we relate how the circle moves, and each point on the circle when we connect all of them when we moving this circle, it can be a pattern like this. This is what we call the cycloid. So cycloid is a pattern, and it has a cycle when you move the circle. Okay. So that's a cycloid, and then vectors. Okay, vectors. I believe, and I hope, and I expect you to know the vectors. Okay, I expect you to know the vectors. Okay. The most notable thing on vectors, aside from what it is and how it's different with the scalar, is the property, the dot product. Okay, the dot product. Dot product, and then the component of vectors. What else? The projections. That the thing that you need to emphasize. And then this is just a 3 dimensions. The idea is still the same. Vectors in space. Okay. Because we will also learn, also in calculus 2, about vectors, and we will relate the vectors with calculus. So we will derive or integrate. Okay. But as long as you're good with vector, the calculus part is easy. Okay. I assure you, it's not that difficult. Not that difficult. Not like when you learn derivative and integration at the first time. So dot product, direction angle, not really. Okay, cross product. This is also important. Cross product. So cross product is we have two vectors, and we need to find a vector that is perpendicular to u and p. That is how we find the cross product. So cross product, and then some explanation here. I hope you watch my video and see if my method here is maybe helpful. Okay, still cross product. Area of parallelogram. Okay. yeah, not really applicable, but you can see how we can use the cross product. Cross product, parallelepiped, volume. Yeah, lines and planes. Okay, I hope you are familiar with this because this is also related to the parametric equations. Okay, parametric equations. Okay, still, and then equation of a plane. Okay, to relate the equation of a plane, we can imagine the same vectors, but we can imagine a plane here, and we have some vector, or what we call the vector n, or normal vector, that is orthogonal to the plane. Okay. So how we find the direction of the plane is through the n, okay, through the n, the normal vector. Okay. So I expect you to also watch my video. Oh yeah, I forgot to attach the exercise last week, so maybe this week I will attach some exercise just to familiar with the vectors, the polar. Okay. Okay. Now the next one is supposed to be what I want you to take. Okay, so we still have. So after vectors, we still have the system of linear equations and metrics, but I think I want to postpone that part and go directly to the conic sections first. Okay, the conic sections. Okay, so what we will discuss today is the conic sections. So conic section. Okay. Why you need to discuss this? At least you will find also in calculus too. At least if you kind of find your own motivations, at least you need to know this for calculus too. Yeah. On the last Friday, I think you guys mostly go to the introduction class, right? I hope you still remember what the speaker says. Fundamentals is important. Okay, at least if you cannot really, maybe sometimes it depends too much to solving questions using formula. I think that part is one way to solve a problem. But in another way, we could utilize all the courses or all the fundamental courses at least to hone our logic, to hone our thinking, okay? How to solve the problem, okay? How to become more critical, okay? At least that way, okay? If you cannot really, because maybe after you graduate, maybe not necessarily applicable, all the courses, but the way you do the courses, the way you solve problems, that is experience, that is the skill set that you are going to have. Okay? So conic section. Okay? So before I'm going through all the details of conic section, why the name is conic sections? It's supposed to relate to cone, right? Okay? But why? Do your teachers in high school tell you why the name is conic sections? Or they used to tell you, oh, conic sections first is this, blah, 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 blah. Okay, conic sections is going to relate with cone. Okay, let me draw two cone upside down like that. Okay. So conic sections means we have a cone, and sections mean we are going to cut. Okay. So imagine we cut here. If we cut here, you will find some curve that is going to, well, you could imagine like that. Like you have something like curve like that. And then if you cut horizontally, you'll find a circle. The cone, you cut how the intersections area, right? And then if we cut a little bit diagonally like that, that's how we find ellipse. Ellipse. Yeah. Okay. Okay, now the first conic sections that you are going to discuss is we call it parabola. It's the same parabola that we discussed on the quadratic equations. Mostly we call parabola. But in the conic sections, we are going to focus on geometry. To the geometry. So let me put some graph. Okay. In conic sections, the parabola defined as, so let's say this curve here is supposed to be our parabola. And then it can be in any axis, and this is just a regular parabola. And imagine there is a point behind this vertex, a point F. This is for focus. But let's say this F is behind this vertex. And in front of the vertex, there is a line we call the directrix. Do not really, maybe if the term's not really familiar, I think still okay, as long as you are going to have a consistent definition. So what parabola means is the distance from the focus to the curve, to any point on the curve, is equal to the distance from the curve to the directrix. For example, this part here is going to be equal to this. When all is equal, then we can assure that this shape is parabola. Okay? In geometric definition. Okay, and we're going to take the second graph, is this one. So to write those definitions in more geometric definition in the formulation, then we are going to take some distance here as our P. Okay. Then this line becomes our y equal negative P if this is on the 0, 0, the vertex. Okay. It's 0, 0. Okay, and then we could take this, the distance. So distance from P to F. Okay. So from this P to here, then we could take that using the xy for P. We could write, and we could say that this will be equal to square root of x squared plus y minus p squared. Okay, that's the distance. And then distance P to directrix, the line. This is going to be y plus b. Right? We just adding this y and then b. Okay, by the definitions, this distance should be the same. Then we could proving this formula. And taking square both sides. So this will be x squared plus y minus b squared equal y plus b squared, or let me just take out. Okay. And this will be plus okay, and then x squared minus 2py equal to py, or x squared is 4py. And this will be the basics on the parabola in terms of geometry, in terms of convex sections. Well, actually, if you think on the any quadratic equations, it's supposed to be having the same parabola, but it will be from y equals something x squared, but that should be the same thing. Okay, in the summary, we could take the definitions right here. Okay, so this is the summary. I hope this is just information. Okay? I hope you don't get confused with this, and I hope not really much information. Okay? The idea is just this equation. It can be this way, the same thing as is your quadratic equations as in your function. When you have a negative, we are going to reverse this upside down. Okay? So no need to worry. The idea behind this convex sections, this parabola version, is we are going to determine the vertex, focus, directrix. Focus and directrix depends on this P. Okay? So when you are maybe asking what is the focus or directrix, it's related to this P. So every time you have, like, for example, you have, let's say, x squared equal to y. Okay. The p will be inside here. So 2 is equal to 4p. So p will be, so this is 2 will be 4p. So p will be half. So the distance will be half. Okay. And then, of course, aside from the x squared, we have the left and right side. We just define the equation with 1 squared equal to 4px. The same thing with the previous one, but the distance should be this distance equal to this distance. Let me just take this, just to note that Okay, seems to be this one. That's to be the distance that we are going to equaling the distance. Okay, that is parabola. Okay, I think not really complicated one, right? Okay. The next two is the ellipses. So this is parabola. This is parabola. The next one is the ellipse. Okay, imagine you have let's say a point here. I'm not sure whether you have tried before or maybe looking at your teachers in your high school. But imagine this big point here as a nail. Okay, a nail, a nail. Okay, and imagine you have a rope or maybe a rubber, maybe a rope. Yeah, a rope, and then you will put your rope here, so it will be tied into this nail. So this is one rope, Maybe I'm drawing not really clear. So and then you are going to use your pen or pencil. And then if you try to make out the shape, a circular shape, around this point, you can make out the shape here. But perhaps it's not really clear. Maybe let me slowly drawing here. Yeah, perhaps like that. Perhaps I bring the tools that I need to find how to. Yeah, you can draw like this. And if you change the locations, maybe getting closer here, it will be more like a circle. And when you have only one point, it will be a circle, right? If you have like a one point, like this, and then you are having the same rope, and then you have a circle, like that. But when we have 2 points, and if we change the positions, it will also change the shape, maybe more elongated, right? And that is ellipse. Okay, that is ellipse. So how we define ellipse from this picture? Do I have a picture more clear? Yeah, I think I have here. So this is what I'm trying to tell you. Okay? So the more we get closer to this point, the more we get a circle. The more we get like having a gap, we have ellipse. And then we are going to define and take those 2 points as our definitions. Okay? So ellipse is all points in the plane that the sum of the distance from 2 fixed points. Okay? So this fixed point here. So if we have in any points here, so if this is here, maybe this and this, all the summations will be the same, constant. So we could say that the distance from PF1 plus distance BF2 is equal to a constant. Okay, to make the formulations more make sense, let me just write a constant with the number 2 and a. Okay, well, you can write like with just a, but to finish off the calculations, it will be better to using 2a. Okay, we will see. Okay, we will see how. Okay, now we can take BF1 and BF2, looking at this distance here, and take C as a distance from F to 0. So we are going to have, so dBF1 is square root of x plus c squared plus y squared, and then for the second one is we are now taking x minus c and then plus y squared, and then this will be equal to a. Okay, and then we move out this part, so 2a minus and then we square each side. Okay, let me expand this, x squared minus 2xc plus c squared, and then we are writing x squared minus 2cx plus c squared plus y squared, and then equal 4a squared minus 4a, and then write all here, x plus c squared plus y squared, and then write plus y squared, and then plus x squared plus 2cx plus c squared. Okay, and then we can simplify it, and taking the cancelling out here, cancelling out again, and cancelling out this one. Now we can write 4a and then equal 4a squared and then plus 4cx. Okay, cancelling all four. And then squaring each side again. So square, take squared. So this will be a squared and then x squared plus cx, 2cx plus c squared plus y squared. Okay. And then this part here is a to the 4 plus 2a squared cx plus c squared x squared. Okay. Okay. So let's multiply each one. This is the same. Let me just copy. Okay. Okay. Let me combine some parts of it. Let me combine this and this. And then all x squared, let me combine all together. So x squared here, x squared here. And this one cancel, right? So a squared minus c squared x squared plus a squared c squared is equal, this should be the y squared, and then we move out the blue one to the right side. Okay, now to finish off this equations, we need to make this notation first. So the distance from the F1 to F2, if this is C, then the distance will be 2C, right? So F1, F2 is 2C, right? And then the whole distance, the sum df1b plus df2p is going to have 2a. And now you need to convince yourself that this 2c is less than the sum of this 2, right? So we could simply say that the 2a is larger than 2c. Or we could say that a is greater than c. So, which gives our conclusion that a squared minus c squared need to be positive. Okay. So this part here is positive. Okay, it's positive value. So because of this positive value, we could define all the terms with a squared minus c squared. So we are going to divide with a squared minus c squared. So first we get a x squared plus a squared y squared, and then a squared minus c squared equal a squared. Okay, and then multiply again with 1 over a squared. So we are having x squared over a squared plus y squared over a squared minus c squared equal 1. And this is getting closer to what we are familiar with. And now we establish that we let some b, some point b, some value b squared is equal to a squared minus c squared. And of course, this is a positive b. And since b squared is less than a squared, or b is less than a, then we could write the equations become x squared over a squared plus y squared over b squared equal 1. This is where a is, or maybe here, let me write, where a is greater b. Okay. So we define a as the greater than b. Okay. Do we need to have a break? No, right? No? So we can finish early? Okay. Yeah. Yeah, yes, sure. Sure. If you haven't eaten your dinner, you can eat dinner. if we let a equal b, then it will be a circle, right? X squared plus y squared equals b. That's the same thing as we did. The point, these 2 points, getting closer to middle, become a circle. And in ellipse, since we have either elongated to x-axis or y-axis, then we have 2 different equations. Okay, now the summary. Okay, this is the important one. If you forget the part here, it's okay. Okay, so we have 2 kind of ellipse. So in ellipse, we will have, we call the major axis, the minor axis. The difference is the major axis is the one that has longest axis. Like for example, the ellipse here is longer on the x, right? So we call the major axis is this one. Okay? So it has the length to a, so a from negative a here, a here. So it's supposed to be in the, let's say, in the center of the origin is the center of the ellipse. Well, this one, the major axis is the vertical line. Okay. And then the focus, the C here, we are going to define C as we defined before, a squared minus b squared. So if this is a, then the b will be the minor. Okay? And if this is a here, the b also the minor here. Notice that the differences is here. B and A is switched. But sometimes other textbook will have their own differences, but still they're still the same. The difference is probably they will write the same, but the difference is maybe one equation A is greater than B, the other one is B greater than A. It's just to say that they both will have a lot of different elongations, different length. Okay, example. Let me write example on the right side. If we have x squared over 9 plus y squared over 4. This y is having 4, x squared having 9 on the bottom. So we need to confirm our a and b, which part of equations this will be. So a supposed to be greater than b, then a squared greater than b squared, and in our case here, a squared will be 9, right? So a is plus minus 3, and b squared is 4, or b is plus minus 2. So c squared is a squared minus b squared is 5, or c is plus minus square root of 5. So the focus, or the foci, will be the plus minus square root of 5, 0, and the vertices, meaning the longest one, the major axis, is plus minus 3. And then major axis length is 6, and minor axis length is 4. Okay. If you want to draw, you could draw. Well, not. It's okay if not precise. I think it's supposed to be like that. Okay. And you can pinpoint all the necessary axes. So I'm drawing axis before, after the ellipse. This is not really a proper way to draw. Should be drawing the axis first and then the ellipse. Let's say here and here, this will be square root of 5. This will be 3. This is negative 3. This is 2. This is negative 2. Okay, now if you look on my ellipse, you will see that how elongated ellipse is, sometimes it has differences. For example, if you look at this one, and my ellipse here, it's different, right? Different shape. This one is more elongated. So this is because in ellipse we also need to consider, we call the eccentricity. So eccentricity. So eccentricity is simply the ratio between C and A. Let me show you. So eccentricity is the ratio in between 0 and 1. And it will determine how the ellipse looks like. For example, I haven't yet cropped yet. Let me crop first. The more eccentricity you have, the more elongated the ellipse will be. Like maybe some like a mochi. Okay. Yeah, I think that's it for the basic on ellipse. Okay. Okay, so parabola, ellipse, the last one is the hyperbola. Okay, so in the basic math in our course, uh, I'm trying to make out all the gaps you have for calculus, or even for the next advanced level of mathematics. Oh, whose phone is that? Okay. So anyway, as long as you can work all the quiz, all the homework, all the well, we have final exam and the final exam. No matter how bad or good the score is, as long as you did all the things, I'm not planning to give you like really bad day on basic math. So, but the most important thing is you need to take all the information in basic math and utilize in your next level courses. Because 6 months or maybe 1 semester, try to keep up and then make sure that you are getting the same pace with the other levels of courses. It's really tough. At least if you want to prepare really good preparation for the entry level of the university level, at least you need to have like 1 year. But now the basic math itself is within the same semester. That's also a problem. So I hope you can keep up the pace. The thing is, no matter what the score you will get in the fundamental courses, the first trial is just your like a trial and error, right? At least you know the level or your own level. Okay? If you can keep up and you analyze within the next semester or maybe next year, even maybe 1 or 2 courses fail, you can take that and then you can take the courses. Because I know you can. And I think some seniors with not really good background in science and or in the STEM level courses, he can do it. So I believe you can do it too. Alright? So if you get like bad score, or maybe next, if you get the final score, maybe you are not past the course, do not feel bad. Do not feel like, I know that in high school or maybe before you came here, having a not pass course seems like shameful story in the family. But that's not always true. Behind those score is your experience. I think one lesson, if you come to Friday classes and introduction, one thing to keep in mind is not your score, but your value. The experience is based on your value, okay? Not based on your transcript. Transcript is just to impress maybe the first impression of the company. But the company not only look your, oh, you get good GPA, oh, you get good course, good score in this course, blah, 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 blah. But they will also tell you, oh, I think you don't have this skill set enough. I don't think you can manage this, blah, blah, blah. I don't think you can handle the responsibility. There's other things that you need to also learn and experience. So I hope you can keep going on. And if you feel bad or maybe feel not comfortable in your first semester, you can discuss with me, with your mentors, okay? And hopefully we can have some solutions along the way, right? Okay. Okay, let me continue. So next is hyperbolas. So hyperbolas is actually similar with ellipse, the way we see, but instead we draw like this, we draw like that. Seems reversing. And in proving the hyperbolas, we are going to subtract, not add. In ellipse, we add the distance. In hyperbolas, we subtract the difference. So let me take the picture. Okay, this is the picture hyperbola. So we are going to have the same P. You can have the P on this side or the P on this side. Okay. So let's just start from this side. Okay. So the P from this side, we are going to have a distance from this F1 and F2. And now, not the sum, but the difference. Okay. The difference. So we will have the distance from P to F1 minus distance from P to F2 as plus minus 2a. Let's say 2a. So if we take the distance formula, let's just make this a constant 2a. And then write the equations x plus c Okay, same way with the ellipse. I will skip the process. Skip the process. Finally, you will see it's the same thing as in the ellipse. You can try squaring both sides and then solving the problems, and then you will see the equations become okay. Of course, we will have the minus, not plus as in the ellipse, and then we need to convince again the distance that the difference is less than 2c. Okay. So if we are going to minus this PF1 minus PF2, this differences is less than this 2c, right? Okay. So we could say that 2a is less 2c, so a is less c, so c squared minus a squared is a positive one. So we could divide this and write becomes x squared over a squared, and then y squared over b squared, and b is our c squared minus a squared. So let b squared equals c squared minus a squared. Okay. Yeah, precisely the same process with the ellipse. Okay. But the difference is we have minus. And of course, you will notice that this negative sign will give you clear differences from the average. Not only different signs, but if you take the intercepts, let's say x equals 0, we're going to have y squared equal minus b squared, which is not real solutions. So that is why we have a branches. We have branches. Okay, let me write the summary in hyperbola here. So all the parabola we did from all the conic section from the parabola, ellipse, hyperbola, we all did in the origin. So the center is origin. Okay. So like this one, we have here, Okay. And notice that we are going to have asymptote in the hyperbola. That is asymptote from this part here, which we can see that this asymptote is based on this ratio B and A. So you can have the hyperbola left hand side or top and down. Okay. And how to notice that is from this part, okay, from the equations, okay, from A and B. You'll notice that A is always positive, B always positive. And on x squared over a squared, this means the A is our major axis on x. The right side, y squared over a squared. So y squared is our major axis. Okay? Or now we call the transverse axis. Okay? Now, how to draw the hyperbola properly? First, we need to find out A and B from the equations and draw the box. And then draw the asymptote. And after draw the box and the asymptote, we can draw the hyperbola. Okay, that's how we draw hyperbola properly. Okay. So draw the box, find A, B, draw the box, draw the asymptote, and then draw the hyperbola. So as long as you can define your A, B, and which hyperbola is it, the later part here is just follow-up of the first definitions. Okay? So you will notice that since this is going to be having the transverse axis on the x-axis, it means that this is going to be B. And asymptote is, if you remember the slope, is y over x, so B over A. And this is also the same, y over x. Now it's A over B. We change this part because of the first part is different in this equation. So it's going to be the vertical. The axis is going to be the vertical. Okay. Okay, so there is another sections in the shifted conics. That is for the conics that is shifted. So it can be shifted parabola, shifted ellipse, and shifted hyperbola. The key is the same. The difference is just the conics will be shifted. Okay. Let me put the picture. Oh, where's the picture? Here. For example, in ellipse, we could take our center, the same thing as in the circle equation. So we are going to move this origin to some point hk, and we define it as x minus h squared, y minus k squared, and then the ellipse still the same. So still the same ellipse, but different locations, different center. Okay. So if we shifted parabola, hyperbola, they're always the same. So we just change our x and y with x minus h or y minus k. Okay, another one. So this is shifted conics. Another one is the general equation of shifted conics. Let me write ax squared plus b okay. A and C are not zero. If A or C is zero, then it will be a parabola. If A and C have the same sign, then it will be an ellipse. Or if A equals C, a circle. If A and C have opposite signs, then it will be a hyperbola. And if, for example, you have this same structure of the equations, sometimes it is not parabola, not an ellipse, not a hyperbola. We call it degenerate conics. So it could be a single line, it could be just a point, it could be maybe no curves at all. Okay, let me give you some idea on how to see this general equation. So in conic sections, there is one more section that I skip, I think. So we will just stop until this shifted conics. The next section is actually about rotations, but since rotations is, I think, take times and it will be too much for this course, so I will just stop here the content. So the conic sections: parabola, ellipse, hyperbola, and shifted conics. Okay, maybe let me explain this. So if A and C are not 0, so we will have a conic, or we call the degenerate conic. The conic will be is 3. Okay. Okay. Let me give you example. So if we have 9x squared minus y squared plus 18x plus 6y equals 0. Okay. The question is maybe draw, maybe sketch, or maybe determine the conics. Because of this part, 9 and negative 1 here, it's supposed to be like hyperbola. But let's try to find. And let's try to prove whether this is hyperbola or not. Okay. So we could start from taking all x and y all together. So let me write with the 9x squared plus 18x minus y squared plus 6y. Let me put 9 here, so we have plus 2x. We can complete the square, plus 1 here, right? And then it's going to be y squared and negative 6y. And then we can complete the square by plus 9, right? So on the right side, we're going to plus 9, right? Because from this 9 here, from the left, and then minus 9. So this will be 9x plus 1 squared minus y minus 3 squared. And it's not equal 1, but it's equal 0. So what does it mean? So if we take this and write in more proper way, like it seems like a hyperbola, but it's equal to 0. So what is this? So if we try to solve, because it's 0, so we could take this y minus 3 squared equal 9x plus 1 squared. If we take this squared off, we will have plus minus 3x plus 1. We could have y equal 3x plus 1 plus 3, or y negative 3x plus 1 plus 3. So we have a line equations, not a hyperbola. So we call this part here, we call the degenerate conics. I think the content for today's up until here. Okay. the shifted point. So parabola, ellipse, hyperbola, and then if we shifted the conics. Although I haven't yet maybe give more example, but I hope from the basics, I hope you get familiar with that. Okay? Maybe giving you more maybe exercise. Okay? So polar, factors, and the conic sections. Okay? I will give these 3 exercises. I think last week I gave you exercise for calculus, right? Chapter 5 and 6, right? 6, right? So 5 and 6 in one paper. Yeah, and I think within this week I will give you this. We just take it as like playing puzzles. Well, you know, mathematics is like a play puzzles, right? Yeah. I don't know.
When we were on lockdown in Russia, yeah, I like to puzzles, but this is not something.
Well, you could think like a puzzle in some way. Like when you did like maybe playing numbers, like you play the what's the name, the Sudoku. It's also math, right?
But that's fun.
Yeah, make it fun. Make this fun. Make this fun. Okay, now because I'm talking about projects and I'm talking about how to make our class much interesting, I want to give the project, okay? But I think I will have my presentation on the other platform. But before the platform, let me give you feedback. Feedback on polar and factors. So you have the notes. You can prepare your notes on the polar and the factors. Okay? I just want to know whether we are having a good learning on the vectors and the polar. If not, then I will give more exercise as well. Okay. Okay. Remember, I think previously I mentioned, as long as you did your homework, your quiz, exam, and make the project. Okay.
What homework?
We only had like 2 homework.
Yeah, if I assign another homework.
Another homework. Wait.
Yeah, check your Moodle. Not yet assigned yet. Haven't yet.
No homework yet.
No homework yet. Yeah.
Okay.
In the future. Okay. At least homework to prepare the final exam, because final exam will consist mostly almost everything. Okay, so let me go to, or let me check first whether I have, so wait for a moment. Oh yeah, I already prepared these slides.
Is final exam in December or January?
Which one you prefer?
January.
Really? Why not in December? So January you will like
that's
more
just-
flexible, right?
That's just the start of the year.
My December is quite cold.
Oh, yeah. I believe you taken more advanced courses. Right?
Yes.
But my plan is actually before the new year, we already finished all courses. But let me try. Let me know your schedule later, okay? Which courses you have, like which finals you have. Okay, this is supposed to be polar and factor, so get ready your notes.
Easy questions.
And your exam, final exam, you can prepare notes. So should be okay, I think. Well, I hope it's not like a nightmare like a calculus one. I know some of you were thinking it's like a nightmare. But I do have good arguments why I prepared the calculus exam like that. Because the quiz was so good. So I expect, okay, you know, and then, okay, I give you. Okay.
My quizzes, it's proportional.
Okay. Okay, get ready. Okay, if you want to join, use your student ID. Okay, don't forget that, so that I can assign some bonus score. Although it's not much, but if you collect more and more, like in calculus, you will be at least taking some decimals up. Okay. Yeah, 3 minutes. I expect to be sufficient. You're taking the polar, and then it's asking the center of the circle. So what part of the notes you need to look at is the conversion, how to convert the rectangular polar or polar rectangular. That those part. Is it?
I think so.
I'm not sure.
No?
Because this is in the polar. And then you need to maybe get out the polar and convert to the rectangular.
Oh, no.
Okay, remember sine and cosine. X is equal to r cosine and y is r sine. Okay? Use that formulation to convert. The conversion is just using that formula for rectangular or the polar. And then using also another one is the tangent is y over x. And next week we will have no classroom, so just additional video. And after that, classroom. I think you did good. Okay, if you're still not sure about this one, you still have like clueless how it goes, maybe I will provide some review on the next video, okay, of this one. Okay, number 2. So I have 4 questions. Okay, get ready. Number 2. Okay, if you maybe take notes or maybe taking picture before, you could see from the table. If you remember, I showed you the table, different polars. Okay. So remember, the lemma sum can have at least 4, or maybe you can make it into 3 different shapes, or 4 if you want to make it complete. The first one is lemma sum with inner loop, the cardioid, the dimpled lemma sum, and the convex lemma sum. Difference is the ratio between A and B. What is A? A is a constant. B is a constant, but attached to the trigonometric. Okay. I think from the options you can rule out the other that is not the lemma sum. So you could see there is just 3 lemma sums, but which one is the one that has inner loop, right? And you could see from that response. Or if you want to browse, you could Google out lemma sum with inner loop. It will give you some image or maybe some descriptions. And you will know how to find this. Okay, good. Okay. Thing. Okay. Who is bad boy? Bad boy. Who is bad boy is I am. Okay. Okay, if you win, let me know, okay? Okay, number 3. Okay, get ready. Okay, area of parallelogram. The clue is related to cross product. Okay, it's related to cross product. But what's happened with the cross product at the end? That's what you know that's related to cross product. Or you can find using your teacher Google. It's Teach Every Kids. It has all the information you need, but sometimes you don't know how to find information. That's the problem nowadays. We are drowned in a lot of information, but we cannot transform those information into knowledge. So there's a problem with your directions. So as long as you have a good direction, good vision, the way you are looking on the Google will be different when you have the knowledge. You can try my method. Do I still have time? cross product. And then after the cross product, what you need to find? The magnitude. You still have time. I already give you the answer. Oh, too bad. Too bad. Okay, try to find the magnitude from that.
Oh. I have to review this.
Okay, 3, 2, 1. Okay, so it's nine square root of 2. Okay.
I got the 9 repair.
Okay. Okay. Now changing the top one is changed now. Okay, last one. Okay, last one. Get ready, last one. Okay, the angle. It's supposed to be easy, right? The angle. Give you some clue. And then find the angle. At least from the 5 options, probably you could rule out 2 because it's impossible to find out. Well, sometimes you could try from geometric perspective, you draw the factors, but I don't think that helps. Yeah, but I think it's just the dot product. It's just the dot product formula. Yeah. Same time. Things need to be more familiar. Okay, good. Okay. So I see the leaderboard. Okay. Okay, congratulations. I'm gonna okay. You get the best results. Okay, now before the attendance, okay, I will explain the project. Okay? The project we did. So this will be the basic math project that I expect to have at the end of our semester. Okay? So the project will be divide all students between two groups. You need to make sure you have your student ID written on this list. Okay, I will also upload this later on the Moodle, so you will not forget. So take time to see your name, or not name, no, your number. And then, I think I need some of the students, I think because mostly IDP students are here. So I would like to have for each one of the groups, so we'll have 8 groups. So maybe one of the students, maybe give me your either email or maybe your phone number. So I will put in the Moodle so that your other members can get you on the phone or on the email. Okay. So maybe the first group, anyone here? The first group? One. And then for the local student, is there anyone here? Not coming, right? So I think either maybe Jelly or Owen, they may know which email, maybe Jelly. Okay, maybe your email. Okay, let me know your email. And then the second group. Okay, one. And then Ayala, and who else? Okay, maybe Ayala. We can give me your maybe email, preferred email. And then you can also check your local students. Yeah, the group 2, yeah, that 2 students, okay. And then group 3, I'm gonna, and next. Is there any local? No? Okay, not coming. This is what I'm afraid of. Some students already asked me because they are not feeling well. So I think maybe next. Okay. Let me give you your email later. And then number 4. Group 4. Local students coming. Okay, local students coming. So I think maybe Peter. Okay. Your email. And then group 5. Which is group 5. 1, 2, 3. Any something? No? Okay. Okay. Who will be the contact number? Or maybe email? Okay. Okay, group 6. Group 6, 1, 2, 3. Okay, local students. Okay, yeah, still in group 6. Maybe Alejandro. Okay, Alejandro. Group 7. Is group 7. Okay, Christian. Okay, no local students. Okay, maybe Christian. Okay, we have your email. And then group 8. Group 8. No one here? Oh, only one. 2. Okay. No local. Okay, maybe Christian. Let me have your contact. Your preferred email. So I'll put all your contact email in the Moodle so that your supposedly members can contact you. So I would like to have all these groups. Okay, within these groups, I need you to have more discussions, more collaborations. Okay, in the next project. So the first thing about the project is you can choose any topics. But it should be related to mathematics. Okay? It's related to math-related topics. You can have the topics from our class like pre-calculus, basic math, or maybe calculus if you want, or maybe any math subject you can choose. Or outside of that, you can still choose as long as it has relations to math. So it's supposed to be really wide spectrum. Okay? And what kind of project? This is example. Okay? Example of the project. Okay? Well, maybe you see some difficult words or maybe difficult terms. But what I want you to do is not really like knowing everything, but just take some time to know, and then, for example, you take maybe cryptocurrency, but can you take this cryptocurrency and then relate this subject into mathematics? Like, of course, in cryptocurrency you have how to check when you do the mining, blah blah blah, right? You can have some sort of checking the security, okay, and then what you need to do is explain, and how you explain is up to you. Okay, it's up to you. Okay, and you can also look at maybe get the combinatorics, statistics, or maybe finance, maybe stock exchange. Okay. So I hope you could do this with more interesting topic that you think, okay, this is relevant and it's fun. Okay, that's supposed to be this project. Okay. Okay. Or if you want to take more all day, you could take some chapter from our courses and maybe take something from there, and maybe we can apply in more interesting applications. Okay. So you could have more examples in the project. So the final result of the project is at least 2 videos. One video is a long video, maybe 20 to 30 minutes is okay. You can record yourself explaining, or using like I did in creating content, maybe using some screen recording. And maybe you can screen record your PPT if you want, or maybe you can make some maybe short animations. I think you could do that, right? Not, I don't think animations with like advanced animations really like. Well, if you could, you can. Okay, but I'm not expecting that. And then after the video, maybe short report. Supposed to be in a PDF file. I'm not really giving you like defining template, like as long as it has the introductions, any literature you read, article, website, it's enough. Okay? And then you have the content and the conclusions. Okay? You can have more, okay? Depending on the topics you take. You can have more in this short report. Because it's short, so you don't need to write everything. Okay? You just need to write necessary things. Okay? It could be just two page, still okay, as long as it is compact, okay? Concise of all the things you make in the video. And then it will be regarded as 35% final exam. Okay? So, as long as you did this, you will still get at least 35% is okay. So I don't, let me rephrase my introduction. I don't want to fail you in this basic math. So as long as you did everything, you should be okay. But try to make this project as interesting as it is. Okay? So try to make as fun as much, okay, as you can. Make the topics is something that you can relate with, and you can have a good discussion with your friends, and international, local Taiwanese, you can have good discussion. Although maybe language will be the barrier, it will be some difficult communication. As long as you can assign each one of you with a good proportions, and you can define your roles evenly, I think you could do it really well. So I haven't write the deadline yet, but it's expected to be in the end of December or early January before the project itself. Yeah. The exam, well, it also around that time, so the same as the final. Maybe just the difference is just 1 week. Okay. Okay, is there anything left? Yeah, I think that's it. So last one, just for attendance. Okay. So if you have any questions regarding the project, let me know. And for the topics, I know that maybe some of you will have maybe same topics. So I will weight your topics first. I will weight your topics and let me know your topics as soon as possible, so that every group has different topics.
We put our email on.
Yeah, you can put your email here with your student ID, the one that I mentioned before. So who else? Cristiano, right? Enela, Sally, Peter, Alejandro, right? And who else? Oh yeah, Dex and Kiwi. Who else I haven't mentioned? Wait, I think already. Oh. Yeah, okay. And that's it for today. Okay, so we finish 8:26. Yeah, maybe right here. Do you still get connection? You can write here. Go to here and just write your email and send it. Yeah, I think it's easy for me to look at this.
Child 405.